Okay. Pretty much where we left off yesterday then. So, um, yeah, we should have enough information to solve number 10 and not go crazy in the process. But we do have to use the VF squared equals VI squared plus 2AD. Let's see here. Is my calculator nearby? I don't know what I did with it. You got it now? Okay. The it's all about that DVAT. All about that DVAT. I understand. Yeah, like when we go through it in class, it's like, oh yeah, that makes perfect sense. And then whenever you like get a problem on your own, it's like, I'm not really sure what's going on here. Okay, so like the Superman problem was like three problems at once. Yeah, I would say that that was probably a long one. So he is going with a initial velocity of 33.5 meters per second. And they all say north, I think. So we're just going to say that to the right is north because I don't really want to draw my picture going up. So if we're going 33.5 meters per second north, he decides to slow to 10 meters per second in a time of 8.05 seconds. So at the second tick of time, he slows down and he's going 10 meters per second. And then he continues his velocity for 12.4 seconds before accelerating at 2.35 meters per second squared until he reaches a final velocity of 23.8. So the third tick of time, he's kind of in between the two with a velocity of 23.8 meters per second. So that means we've got three different chunks of time. We've got the first one where we have an acceleration of, he says it's slowing down, so isn't that negative? And I think it told us what it was. Oh no, it just told us the initial velocity and it gave us a time. So I don't know. I'm a big fan of the DVAT, so I think I'm going to just do that. Let's go ahead and just say that this is one chunk of time, and then this is another chunk of time. So we know that he's flying originally at 33.5, and then he decides to slow down. So let's just write down everything that we've got from our DVAT, and we'll move on from there. So, let's see here. D, VI, VF, A, T. DVAT. Do, 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 do. Do we have a distance? Negative, Ghost Rider. Do we have a velocity? Yeah, 33.5 meters per second. Do we have a final velocity? It's not zero. Hang on. I was thinking of the water rocket. It slows down to 10 meters per second. Um, do we have an acceleration? We don't know. Okay, not yet. Do we have a time? 8.05. Somebody's like really taking a stopwatch to this guy. 8.05 seconds. So VI, VF, T. That gives us, I think, enough information. The forbidden equation. Are we using the forbidden equation? Calculate the displacement. Okay, yeah, I think that's generally a good idea to do that. So, forbidden equation. Displacement equals VI plus VF over 2 times the time. Red because you're going to have to memorize it if you want to use that one. I think we've got everything. So that's 33.5 plus 10 meters per second divided by 2 multiplied by the time, which was 8.05 seconds. Whatever that is, that comes out to be the displacement. Okay, so 175.1 meters. I'm going to write over here 17. Nope, 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 nope. Superman problem. Write that over here. 175.1 meters. Calculate Superman's average velocity for the entire flight. So to do that, you just have to do total displacement over total time, which means we need to calculate what the displacement of this other side is. We know that this part is 175.1, but to do the average velocity, which I'm going to write as v bar, that's going to be total d over total t. So we have to add them all together. Okay, so that means that we need the displacement on the other one. That's going to be a different dvat, so I'm going to erase the dvat that we have, and probably going to use a different equation too. So I'm just going to erase this stuff, and see what we're doing. Okay, so on the second part of the problem, we don't know the displacement. We know the initial velocity is 10. We know the final velocity is 23.8. I'm going to write meters per second because part of me is OCD that way. Acceleration, I think it gives it to us, right? 2.35, yeah, thank you. 2.35 meters per second squared, and the time they did not give us this time. So we got to use a different equation. The forbidden equation will not work. So, yep. Oh crap. Yeah, I completely forgot the fact that in the middle he goes at a certain velocity for 12.4 seconds. Yeah. Um, what is that speed that he's going at that point in time? Okay, so what I need to do is in this problem, I need to break this up again. So it's 175.1, and then he slows down to 10, and then he keeps going 10 meters per second. I forgot about that part completely. And then, so this gives us, fortunately, this section is easy because there's no acceleration happening. We're starting at 10, we're ending at 10. So we can calculate that one pretty easy. If you're going 10 meters per second for a total time of 12.4 seconds, that's just velocity times time. So that's going to be 10 times 12.4. Isn't that 124 meters? Okay. Fortunately, that one was easy. Um, the last part with the going to 10, then going to 23.8, and then having an acceleration, we have to use a kinematic equation. It's not terrible, but we're actually going to have to probably solve for it with math. So, which one do you want to use? Okay, so we have VF squared. Let's see if we've got everything that we need. VF squared equals VI squared plus 2AD. I am looking and I'm seeing VF is 23.8 meters per second. So that's, yeah, we can, do we have time? No, we need the distance. I think you're doing it right. So it's 23.8 squared. The VI is 10, so that'd be 10 squared, plus 2 times whatever they gave us, 2.35 times d. We have everything except for d, so I think this will work. We can find the displacement this way. We're just going to have to worry about those squared numbers, which can be resolved pretty easily. So I'm going to do 23.8 squared. That's 566. So 566.4. 10 squared is 100. 2 times 2.35, 4.7. Take away 100 on both sides. 4 equals 4.7d. If we were rounding up, these numbers would work out really nicely. 466.4 divided by 4.7. So I got about 99.2 meters. Do y'all agree with me, or did I screw up somewhere? You got it? You got it? You got it? Okay, good. All right, so we have all three of those. So we know that the third distance is 99.2 meters. So we have the first distance, we have the second distance, we have the third distance, and we're just going to have to add the total distance together and, oh crap, divide it by the total time. We do need the time for the bottom part. Yeah, we do need the time for the bottom part because to find the total average velocity, 6 seconds. Okay. So, what reasoning or formula did we use to get for 6 seconds? Okay. Yeah, you can use VF equals VI plus AT, and you can find out that the time for the third part is indeed 6 seconds. I will go with that. That seems believable. You could also make a velocity argument as well too, since you know that it's going from 10 to 23.8. You can count by tick marks every second you're going to gain 2.35 meters per second. So you can just count by 2.35s until you get there. That's another way to do it, but most people are just okay with the VF equals VI plus AT. And that will, either way will work just fine. So the total displacement, I think we have everything, is going to be all of the highlighted yellow, 175.1, 124, 99.2, and then all the times we'll get mainly from the problems. There's 6 seconds for the time. There is 12.4 seconds, and also, where's the third one? 8.05 seconds. So we're going to add those together. What is our total displacement? Roughly 400? Okay, so can I put 400 there and be okay? All right. There's three times. There's one time, 8.05 seconds. There's 12.4 seconds, and then we calculated 6 seconds. So we're going to have to add those three together. 8.05 plus 12.4 plus 6, 26.45. 26.5, whatever. So total distance over total time will give us our average velocity, and that's 400 divided by 26.5, 15.1 meters per second. Average velocity, about 15. That was a long problem. Definitely a long problem. Why would I do that to you guys? Oh yeah, because it's AP Physics, that's why. I figure if I can hurt you guys enough whenever you get to the AP test, you'll be like, that actually wasn't so bad, and everybody else is crying. That's pretty much how that works. Yeah. Yeah, get you guys ready for the challenging stuff. If I don't challenge you now when you do the AP test, it's gonna be like, oh, this is difficult. But you did not leave enough room for Superman. Clearly he takes a. That's fine. That's every time I do a problem, I try to make it as unjumbled crap as possible. But sometimes that ends up happening. Sometimes you think that it's a quarter page problem and it turns into an entire page problem. I understand. I really do. Any other questions about the homework, or y'all still need just some time to tackle the other stuff? Okay, then I will let you guys have some time. It's not going to hurt my feelings as long as you're using it productively. Digital people, I think this is due today, so try to finish it up as soon as possible.